Hey, this is Audra Needham, and I'm here to talk to you today a little bit about MRI. A little background on me: I've been a registered MRI tech for approximately 15 years, certified in MRI safety for approximately 2, so I'm very passionate about MRI. MRI is a great tool that your doctors can use to see what's going on inside your body. But there's a lot of misinformation out there, especially what you see on TV about the things that MRI can and can't do. So hopefully I can clear up some of that for you today. The 3 things that I want to cover briefly are about the magnet. The magnet's always on. It's a giant electromagnet. There are some dangers associated with MRI, and there are ways that you can help us. There are ways that you can help keep yourself safe and help us get great images. So to start with, what is MRI? MRI stands for magnetic resonance imaging. The physics of how MRI works is very complicated, and I'm not going to go into that a whole lot. Basically, it's a giant electromagnet, and the body is also a magnet. The body has magnetic properties because of the cells inside of it. A research journalist at Science Editor BMJ named Abby Berger compared the hydrogen protons in the body to tiny bar magnets in the way they spin. So when you put the body inside the scanner and apply a radio frequency pulse, that's how the images are created. Again, very complicated, not really going into a lot of the physics. The main thing you need to know is that it's a very strong magnet. To give you an idea of how strong the magnet is, we compare it to gravity. Well, gravity is measured in a unit called Gauss. NationalMagLab.com says gravity is equivalent to half a Gauss. A strong refrigerator magnet is equivalent to 100 Gauss. Well, it takes 10,000 Gauss to make 1 Tesla. Tesla is what MRI is measured in. That's the unit that MRI is measured in. So a typical magnet in the United States, the most common used is a 1.5 Tesla magnet. So that would be 30,000 times Earth's gravity. So the 1.5 Tesla magnet that you're getting scanned on, that most people get scanned on, is approximately 30,000 times stronger than the Earth's gravity. So it's pretty strong. So we've established that we have a pretty strong magnet. And because it's an electromagnet and applying the electricity, we can't turn it off. Now, to talk about some of the dangers, when you think of a magnet, you think of metal and things that pull to the magnet. Well, there's different kinds of metal. Ferrous metal, or metal that will pull to a magnet, is what we worry about in MRI. Some examples of ferrous metal are iron, nickel, and cobalt. Non-ferrous metals would be gold, silver, and copper. Ferrous metals pull, as we established. So if you come into the scanner, we want you to empty your pockets out. We want you to take out your pocket knives, phones, guns, anything like that. Now, most surgical implants are fine. Those are made out of metals that are not ferrous. So most surgical implants don't cause you any problems. Another problem that you can run into with MRI is because of the electromagnet, it can induce a current. When you move the body through the electromagnet, the magnet moving through the electromagnet, it can induce a current. So any metal can have a current induced through it as well. So zippers might pull because of the ferrous nature of them and just the magnet itself. Buckles might pull. Underwire bra could actually pull, or there could be a current induced through that. Those are some of the common things that people might think of. Some things that you might not think of are like shanks in a boot, safety pins that may have been left in your clothing. A lot of clothes are made now with metallic microfibers. Business Insider actually published an article about people being burned by their leggings. We don't want you to cross your arms or legs when you're in the scanner, because those points where the skin touches actually close the circuit and a current can be induced there and you can be burned. Another danger is noise. You can actually have hearing loss from MRI because the coils inside the machine vibrate at such high frequencies and so loudly that it can cause hearing loss. So we've talked about some of these dangers. Now let's talk about the things that we're going to do to help keep you safe and how you can help keep yourself safe. The first thing that you can do is be honest with us. We're going to screen you when we start your test, or before we start your test. We're going to go over a whole bunch of questions. Be honest with us. You're not going to shock us. I'm not going to say we've heard everything, but we've heard a lot. Just be honest with us about anything that's in your body, on your body, any surgical histories. We need to know that stuff before you go in so that we can keep you safe. We're going to give you a gown to change into. If we don't give you a gown, ask for a gown. You absolutely can ask for a gown to help us. We're going to possibly scan you with a metal detector. We're going to give you earplugs. Use those earplugs. We might be able to give you earphones to help with the noise and let you listen to music. Another thing is hold still. If you're holding still, then we don't have to repeat any of our scans. So these are all ways that you can help us get you a good scan. So the things I want you to remember about this. Okay, the magnet is not like what you would see on Dr. House, or as Dr. House would have you believe. It's not going to pull a bullet out of your arm that's been there for years, but you do need to exercise caution around it. It is a strong electromagnet. It's always on, and the physics are complicated. It is dangerous, but operated safely and operated correctly, it is safe. And we need your help to do that. We need your help to get those great images to give to your doctor.